Let's see if this is working. Test, test. Let's see if I can hear myself. Alright, seems it is. So, let's get started with our lesson. Last class, we started up the topic of matrices. What are matrices again? They're essentially just a different type of notation for determining groups of numbers. They're by in specific dimensions with a clear width and a height. This height can change, it can turn into A, B, C, E, F, G, be something like width of 3 over a height of 4, or maybe a width of 5 over a height of 1. And just like that, that's essentially just all it is. So, last class, we talked about how matrices interact with each other. When you add matrices, you can only add or subtract matrices that are of the exact same. You can only add and subtract matrices that are of the exact same dimensions. So you can't add something that's like 2 by 3 to something that's only 2 by 2. This is not allowed because there's like A, B, C, D, E, F, A, B, C, D. Because let's say each thing needs to correspond to something, but there's nothing for these two things to correspond to. Same rule applies for subtraction essentially, and we talked about how multiplication with numbers works for matrices. If a number is next to the matrix, you just apply that number to all the matrices. So this equals 1, 1, 4 over 5, 2, 1. So now we've done like a quick review of what we did, let's go over to today's lesson. The main lesson that we want to do today is we're gonna multiply matrices by matrices. So we've essentially when you normally multiply a matrix, it's essentially a multiplication of oh this width by these heights. Essentially, we're looking at by a 2 by 2 matrix right now, but to take example, essentially this new matrix. So essentially, you multiply this to this, then you add it to this times this. And for here, you do the same for here, and for here, on and on. Now, when can you multiply matrices? Well, because well, if they're the same dimension, they always work, but what makes it correct? So when we're doing this here, we're multiplying the width by the height, right? The height of this does not matter. We just multiply as many at times as there are. As long as the width of this is 2 and the width and the height need to equal. But what you need to remember is that orientation clearly matters. Yeah, orientation clearly matters. So what I mean by this is let's draw this out. A, B, C, D. This is a 2 by 2 matrix times, if this was a 2 by, yeah, let's say this is a 2 by 3 matrix. This is A, B, C, D, E, F. Say we have this here, right? We multiply these two together. We get 2 by 2, and then oh shoot, my bad. Let's just make this 2 by 3 here. 2 by 3. Right. So we have this here, right? Essentially, when you write out the heights and the width of the first one and the height of the first one need to be equal. And when they do, they cancel out. And what you are left with is a 2 by 2 matrix as the product. Let's see how wide this is. So we multiply this out, right? So first we multiply this whole row by this whole row. This is a squared plus bc plus e squared. That's the first term. The second term, we multiply this by here, this by here. So it's AB plus BD plus EF. Now down here, CA DC EF plus, and down here, multiply CB D squared plus, CB plus D squared plus F squared. Now, if you were to reverse this, so let's say we multiplied a 3 by 2 matrix times a 2 by 3 matrix, even if it were these two the same matrices and you just changed the order of which one was being multiplied to what, it would give you a 3 by 3 matrix instead. Let's try some more let's try some bigger examples with this. By a 4 by 2. Oh wait, no, this does not work. 3 by 2 matrix. 5 times 3 matrix by a 3 times 2 matrix. Say, select something like we need more room. 1 0. If they get too big, it gets out of hand to try to calculate with a calculator. By that I mean the numbers, because we're essentially adding all of them together. So we know that the result is gonna be a 5 by 2 matrix. By 2 matrix. Let's see what it should look like. So take this row here, multiply to here. 0 plus 6 plus 0. Multiply this to here. 1 plus 2 equals 3. Next row. 5. Next row. 0, 1. here. 0, 9, 13. That's probably the biggest we're gonna get. And 5 down to here. 1, 1, 0, so 0, 3. 3 times 2, 6. 5, 8. 1, 1, 1, 1, 0. So 2, 6, 3, 6, and then 3. You can see here, we get a 5 by 2 matrix. Now, now that we've covered multiplication, you might be wondering, how do we divide matrices? Well, the thing is that we can't exactly divide a matrix by a matrix. Uh, Essentially, what we need to do in those situations are we multiply a matrix by the inverse of the matrix we want to multiply by. But first, what is the inverse of a matrix? Well, first of all, if you have a matrix and you just on a calculator, going into math, edit, and doing all that, you can you can just type the -1 symbol, and most of the time it will do it for you. Most of the time, you won't have to calculate for a matrix without a calculator because it gets really tough. However, something that is really simple is in the case when you need to solve for 2 by 2 matrices. For 2 by 2 matrices, the logic itself is really simple. So, let's say matrix A is equal to A, B, C, D. The inverse of this is equal to 1 over AD minus BC over D minus B minus C A. So essentially, as you can see here, the place of A and D gets swapped, and B and C become negative. And it's essentially multiplied by 1 over the multiple of this minus the multiplication of this. And if you were to multiply A by uh, A minus 1, you would get you would just get 1. Now, this is because in this case, it's essentially just 1 over A, which is effectively the same as dividing something by something. So let's try finding the inverse of some 2 by 2 matrix. The larger the matrix gets, the more different the rule is, so it's just easier to like just memorize that rule for now. Say for 3, 3, 2, 6. We multiply this. So first, on the outside, there's a fraction to it multiplied by AD. So 18 minus 6. And this becomes 6, 3, -3, -2. This 18 minus 6, this is equal to 1 over 12. So you divide everything in here by 1 over 12. So this becomes 1/2. This becomes -1 over 4. this becomes negative 1 over 6, and this becomes negative 1, just positive 1 over 4. And if you needed to divide b by reciprocal of a, the inverse of a, let's say b is equal to 3, 2, 4. Well, they're both 2 by 2. We multiply this to here. So it's 3 over 2 minus 1 over 3. And here, 2 over 4 minus 3 over 4. It's 3 over 2 minus 1 half. Negative 3 over 4 plus 1. And that's essentially you need to do when you need to divide the matrix of B by A. You need to find the inverse of the matrix and multiply it to the original matrix. It's probably gonna be the end of the matrix units. I don't, at this level, you don't actually, first of all, you don't use matrices, like, at all in calculus. I guess they sometimes use it in the usage of cross multiplication, but it's just like a different method to do it that's not essential, and they don't actually test you on it. It's just like another option that you can do, but most of the time it's honestly slower to write out the matrix. So this is essentially all you need to know for matrix. On most matrix quizzes that you will get or test, you will have access to a calculator, so plugging in things should be easy enough. The main thing to gain out of what this is, it's just a concept that when you multiply a matrix, so matrices, multiplying order matters. B times A is not equal to A times B when they're both matrices. Distributive property still applies. CA plus B does equal CA plus CB. When you apply, you can only multiply two matrices that have a matching width on the first one and a height on the second one, and the result is the height of the first one and the width of the second one together. And when you divide a matrix, you find the inverse, which you get by this equation here, but that's only apply for 2 by 2 matrices. Each dimension has like different equations for finding it, and you just simply multiply it by the inverse. That's going to be it for today, and have a good night.